Now, in this lecture, we'll find out the length of chord AB. In the drawing, we have a semicircle, and inside this semicircle, we have three circles. Those two small circles are identical, and the middle circle is tangent to the semicircle at point O. Point O, it is also the center of the semicircle, and point C is the center of the middle circle. And we know that PQ, that is the diameter of the semicircle, equals to 8 units, and the diameter of any circle is twice as large as the radius. So if the diameter PQ equals to 8 units, then the radius will be equal, the radius of the semicircle, this semicircle will be equal to 4 units. That is to say, PO, that is the radius of this semicircle, it equals to 4 units in its size. And OQ, that is also the radius of the semicircle, it equals to 4 units. And OX, that is also the radius of the semicircle, equals to 4 units. But OX is not only the radius of the semicircle, but it is also the diameter of the middle circle, of this middle circle. And the diameter of the middle circle equals to 4 units. It means that the radius equals half of it. The radius of the middle circle will be equal to 4 over 2 units. That is to say, the radius of the middle circle equals to 2 units. That is to say, CX, that is the radius of the middle circle, equals to 2 units. And OC, that is also the radius of the middle circle, equals to 2 units. And we will define the center of the small circle as point M. We will join points M and C by a straight line. MC, it is actually the distance between the centers of those two circles, of the small circle and the middle circle. And if we define the radius of the small circle as R, then this will be equal to R. We will define the touching point between the two circles as Y, and we know that OY or CY equals to 2 units. This is the radius of the middle circle. And actually the distance between the centers of those two circles that have an external lunge between them, it equals to R plus 2. Okay? Then we will join together, we will define the touching point between the tangent PQ and the small circle as point N, Sn. Then we will join points M and N together by a straight line. Actually, Mn is the radius of this small circle, that is to say, it equals to R. And we have the radius Mn that is drawn to the point of tangency, that is to say, it is drawn to point N, that is the point of tangency of tangent PQ with this small circle. Therefore, the tangent PQ is perpendicular to this radius. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, the radius CO of the middle circle is drawn to the point of tangency, that is to say, it is drawn to point of tangency point O, that is the point of tangency of tangent PQ with this middle circle. Therefore, the tangent PQ will be perpendicular to this radius, that is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, now I will draw the quadrilateral MNOC in a new page. So I draw the quadrilateral MNCO again. We will define this point as point D. And we know that AB is parallel to PQ. Okay, AB is parallel to PQ, and if AB is parallel to PQ, it means that ND also parallel to MD, because it is part of MD is part of AB and ND is part of PQ. Therefore, we know that NO is parallel to MD, and we have the rule that states, according to rule number 1, corresponding angles between parallel lines are equal to each other. According to rule number 1, corresponding angles between parallel lines are equal to each other. So I will write it down. Corresponding angles between parallel lines are equal to each other. I will read rule number 1 again. According to rule number 1, corresponding angles between parallel lines are equal to each other. And here we know that MD is parallel to NO, MD is parallel to NO. Because of the fact that MD is parallel to NO, then those two corresponding angles that are located between the parallel lines MD and NO will be equal to each other. Okay? So angle NOD equals to angle CDM according to rule number 1. Okay, angle NOD equals to angle CDM according to rule number 1, because those angles are corresponding angles that are located between the parallel lines MD and NO, therefore they are equal to each other. But we know that this angle NOD, or it is actually angle MOD, it is actually angle MNO. Yeah, it is actually angle, I relate to this angle, it is actually angle CON. Angle CON equals to angle CDM. I repeat again, angle CON, this angle equals to this angle CDN, because those two angles are corresponding angles and they are equal to each other because they are located between the parallel lines MD and NO, therefore according to rule number 1 they are equal to each other. I'll repeat again, angle CON equals to angle CDN because those angles are corresponding angles that are located between the parallel lines MD and ON, therefore they are equal to each other. But we know that angle CON is a right angle, it equals to 90 degrees. So angle CON, it is a right angle, therefore it equals to 90 degrees. And from this equality, we will conclude that angle CDN also equals to 90 degrees. Angle CDN also equals to 90 degrees. Okay, angle CDN equals to 90 degrees. So this angle, it is a right angle. It equals to 90 degrees. And here we have also, we will define this point as point E. So I will draw the segment line YE in this drawing. This will be the segment line YE. Actually, here I will draw perpendicular from point M to CO. Therefore, this angle will be equal to 90 degrees. It is a right angle. And this angle will be also equal to 90 degrees. It is also a right angle. And then we will define this point as point D. Actually, those two angles, they are equal to each other. Why they are equal to each other? Because of the fact that AB is parallel to PQ. If AB is parallel to PQ, then YE, it is also parallel to NO. Again, YE is parallel to NO. YE is parallel to NO. And those two corresponding angles, they will be equal to each other according to rule number 1. Those two corresponding angles that are located between the parallel lines YE and NO will be equal to each other. So again, YE is parallel to NO, and therefore, according to rule number 1, angle NOC, this angle equals to angle CEY. So angle NOC equals to angle CEY. But we know that angle NOC, this angle, it is a right angle. That is to say, it equals to 90 degrees. Angle NOC, it is a right angle, it equals to 90 degrees. So from this equality, we will conclude that angle CEY equals to 90 degrees. Angle CEY equals to 90 degrees. It is a right angle. That is to say, this angle, angle CEY, it is a right angle. It equals to 90 degrees. Okay. Likewise, we know that YE is parallel to NO, therefore those two corresponding angles that are located between the parallel lines YE and NO will be equal to each other. That is to say, angle, this angle that is a right angle, that is to say it equals to 90 degrees. This angle, it is a right angle, it equals to 90 degrees, will be equal to this angle, we will define this point as point B, will be equal to angle CEB. Okay? According to rule number 1, those two corresponding angles are located between the parallel lines YE and NO, therefore they are equal to each other, and this angle equals to 90 degrees. So this angle will be also equal to 90 degrees, or angle CEB will be equal to 90 degrees. Angle CEB will be equal to 90 degrees, that is to say, this angle is a right angle. Okay, angle CEB equals to 90 degrees, that is to say, this angle it is a right angle. And here MN is the radius of the small circle. So here we write down that MN equals to R, it is the radius of the small circle. And we have a rule. So this angle, it is also a right angle, because we draw perpendicular from point N to CO, so those two angles are right angles. So if you focus on quadrilateral MDNO, on quadrilateral MDNO, we have three right angles, and I will present to you rule number 2. Rule number 2 states that the sum of the angles in any quadrilateral equals to 360 degrees. According to rule number 2, the sum of the angles in any quadrilateral equals to 360 degrees. So I'll repeat on rule number 2 again. According to rule number 2, the sum of the angles in any quadrilateral equals to 360 degrees. And if we focus on quadrilateral MNOD, the sum of the angles in quadrilateral MNOD must be equal to 360 degrees. And quadrilateral MNOD has three right angles, 1, 2, 3, and the sum of those three right angles equals to 360 degrees. And it equals to 90 times 3 is 270 degrees, plus the size of the fourth angle that we will define as angle X. The must be equal in total to 360 degrees according to rule number 2. I will repeat again. If you focus on quadrilateral MNOD, the sum of its angles must be equal to 360 degrees according to rule number 2. So quadrilateral MNOD is three right angles that equals to 270 degrees in total, plus the fourth angle. Those four angles in total must be equal to 360 degrees according to rule number 2. Here we will subtract 270 degrees from this equality, and we will get that angle X equals to 360 degrees minus 270 degrees is 90 degrees. So we found out that angle X is the right angle, it equals to 90 degrees. Angle X is the right angle, it equals to 90 degrees. So you can write here that this angle is the right angle. Okay, equals to 90 degrees. So as you can see from the drawing, quadrilateral MNOD has four right angles. And we also have rule number 3. Rule number 3 states that any quadrilateral that has four right angles must be at least a rectangle, if not a square. So I will write down rule number 3. According to rule number 3, any quadrilateral that has four right angles must be at least a rectangle. Rectangle, if not a square, it must be at least a rectangle. Okay? So quadrilateral MNOD must be at least a rectangle, if not a square. Okay? According to rule number 3. And we also have rule number 4 that states that the opposite sides of a rectangle are equal to each other. The opposite sides of a rectangle are equal to each other. So I will read rule number 4 again. Rule number 4 states that the opposite sides of a rectangle are equal to each other. The opposite sides of a rectangle are equal to each other. So here we know that MN equals to R and MN equals to DO according to rule number 4. MN equals to DO. Okay, according to rule number 4, MN equals to DO because MN is located in the opposite sides of DO in rectangle MNDO. Therefore, MN is equal to DO. This is according to rule number 4. I'll repeat again. MN equals to DO according to rule number 4, that the opposite sides of a rectangle are equal to each other. But we already know that MN equals to R. It is the radius of the small circle. So we can write here that MN equals to R. So from this equality, we will conclude that DO also equals to R. DO equals to R. So we can write here that DO equals to R. And what is the value of CO? The value of CO, we can see in the original drawing that CO is the radius of the middle circle, that is to say it equals to 2 units. So CO equals to 2 units because it is the radius of the middle circle. And we know that DO equals to 1. And CO minus CO minus DO equals to CD again. CO minus DO equals to CD. I will write it down. CO minus CO equals to CD. CO minus DO, CO. I'll repeat again. CO minus DO equals to CD. CO equals to 2 units and DO equals to 1. So in total we found out that CD equals to 2 minus R. I'll repeat again. CO equals to 2 units and DO equals to R. Therefore, CD equals to 2 minus R. So we can write here that CD equals to 2 minus R. What is the value of MC? We've already found out that MC, that is actually the distance between the centers of the small circle and the middle circle, it is actually equals to R plus 2, that is the sum of the lengths of the radiuses of those circles. So MC equals to R plus 2. You can write here that MC equals to R plus 2. MC equals to R plus 2. So we focus on the right triangle, triangle CDM. So on the right triangle, triangle CDM, according to Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle, triangle CDM, it is actually CM, therefore the square of the hypotenuse is CM square, and it equals to the sum of the squares of the perpendiculars, that is to say it equals to CD square plus dm square. Plus dm square. So in the right triangle, triangle CDM, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say CM square equals to CD square plus DM square. But we have already found out that CM equals to R plus 2, therefore CM square will be equal to R plus 2 square. And it equals to CD square. CD equals to 2 minus R. Therefore CD square will be equal to 2 minus R square plus dm square. I will repeat again. Cm equals to R plus 2, therefore Cm square will be equal to R plus 2 square. CD equals to 2 minus R, therefore CD square will be equal to 2 minus R square. and dm square equals to dm square. Here we will open the brackets on both sides of equation number 1, and we will get that r plus 2 square equals to r square plus 4r plus 4, and 2 minus r square equals to 4 minus 4r plus r square plus dm square. So here we have r square in both sides of equation number 1, so r square will get cancelled, and we also have 4 on both sides of equation number 1, so 4 will also get cancelled. And what is left after we cancelled those expressions from equation number 1? What is left here? What is left is 4r, and what is left in the other side of equation number 1? What is left? It is actually minus 4r plus dm square. So here we will add 4r to this equation, equation number 1, and we will get that 4r plus 4r is 8r equals to 4r minus 4r is 0, so 4r equals to dm square. Here we will take a root out of equation number 1, and we will get that dm, according to equation number 1, dm equals to the square root of 8r. We found out that dm equals to the square root of 8r. We know that 8 is 4 times 2, so we will substitute 8 in this equality by 4 times 2, and we will get that dm, according to equation number 1, dm equals to the square root of 4 times 2 times r. The square root of 4 is 2, so we write it down. We will get the dm equals to 2 times square root of 2r. We found out that dm equals to 2 times square root of 2r, so we can write here that dm or mdt is the same, equals to 2 times square root of 2r. Okay, and we have the rule number 4 that states that the opposite sides of a rectangle are equal to each other. Therefore, MD will be equal to NO. So MD equals to NO according to rule number 4. MD or DM equals to NO according to rule number 4. But we know that MD equals to 2 times square root of 2r. So we can write here that MD or DM equals to 2 times square root of 2r, and from this equality we will conclude that NO also equals to 2 times square root of 2r. Okay, so we can write here that NO also equals to 2 times square root of 2r. Then we will connect together points M and O by a straight line. And we will find out the size of MO. We will connect together points M and O by a straight line in the original drawing. And we will also connect together points M and A by a straight line. Actually, MA is the radius of the small circle, that is to say it equals to R. And what is AO or OA? OA is the radius of the semicircle. Therefore, it equals to 4 units. AO or OA is the radius of the semicircle, therefore it equals to 4 units. We know that AM equals to R, it is the radius of the small circle. So AO equals to 4 units and AM equals to R, the radius of the small circle. And what is the length of MO? The length of MO from the drawing, you can see that MO equals to AO minus AM, very simple. AO minus AM equals to MO. AO minus AM equals to AO equals to MO. I repeat again. AO minus AM equals to MO. But AO equals to 4 units. And AM equals to R. So in total we found out that MO equals to 4 minus R. MO equals to 4 minus R. So we can write here that MO equals to 4 minus R. And we will write here also that MO equals to 4 minus R. Then we will focus on the right triangle M and O. On the green right triangle M and O. So here we will implement the Pythagoras theorem on the green right triangle M and O. According to the Pythagoras theorem, in the green right triangle M and O, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is MO, therefore the square of the hypotenuse is MO squared. It equals to the sum of the squares of the perpendiculars, that is to say it equals to mn squared plus no squared. So I'll repeat again. In the right triangle, triangle MNO, according to the Pythagoras theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, MO square equals to MN square plus NO square. But we have already found out that MO equals to 4 minus R, therefore MO square will be equal to 4 minus R squared. MO square equals to 4 minus R squared, and MN equals to R, therefore MN square will be equal to R squared plus NO square. NO equals to 2 times square root of 2R, therefore NO square will be equal to 2 times square root of 2R squared. So in total we got that 4 minus R square equals to R square plus 2 times square root of 2R square. Here we will open the brackets in equation number 2, in both sides of equation number 2, and we will get that 4 minus R square, it is actually equals to 16 plus R square minus 8R, and it equals to R square plus the square root of 2 times square root of 2R square is 8R. So here we have R square on both sides of equation number 2, so R square will get cancelled. In the next step we will add 8R to this equation, equation number 2, and we will get that 16 equals to 8R minus 8R is 0, and 8R, so 16 equals to 8R plus 8R is 16R. So here we will divide equation number 2 by 16, and we will get that R, the radius of the small circle, equals to 16 over 16 is 1, so R equals to 1 unit. We found out that R equals to 1 unit, so we can write here that R, the radius of the small circle, equals to 1 unit, R equals to 1 unit, and CD equals to 2 minus R. And R is 1, so 2 minus 1 is 1, so CD equals to 1 unit. And then we will focus on the right green triangle, triangle CEY, and we will also focus on the right triangle, triangle CDM. And we will prove that those two triangles are similar to each other. So we will focus on triangle CY and triangle CDM. We will prove that those two triangles are similar to each other. First of all, those two angles are right angles and they are equal to each other. So this angle CEY in triangle CEY, equals to angle CDM in triangle CDM, and they are both equal to 90 degrees, they are right angles. I will repeat again. Angle CY equals to angle CDM, and they are both right angles, they are equal to 90 degrees. And we have this angle C. It is a common angle, it belongs both to the green triangle and also it belongs to the right triangle, triangle CDM. So we can write down that angle C equals to angle C is a common angle that belongs to both triangles. Angle C equals to angle C is a common angle that belongs to both triangles. I will repeat again. Angle C equals to angle C is a common angle that belongs to both triangles. And we have also those two angles, they are equal to each other according to third angle theorem. So this angle CYE in triangle CYE, equals to this angle CMD in triangle CDM, and they are equal to each other according to third angle theorem. I will repeat again. Angle CYE equals to angle CMD according to third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And here we have this is the first pair of angles that congruent in those triangles, and this angle is a common angle. It belongs to both triangles, so this angle equals to itself. So this is the second pair of angles that congruent in those two triangles. Therefore, according to third angle theorem, the third pair of angles must also congruent. Those angles are the third pair of angles that must also congruent. That is to say, angle CYE in triangle CYE equals to angle CMD in triangle CDM. Those two angles must also congruent according to third angle theorem. So we actually proved that all three angles in triangle CYE, 1, 2, 3, congruent to all three angles in triangle CDM, 1, 2, 3. Therefore, we proved that triangle CYE is similar to triangle CDM according to angle similarity rule. I'll write it down. We actually proved the triangle CYE is similar, this is the sign of similar, to triangle CDM according to angle similarity rule. repeat again. We proved that triangle CYE is similar to triangle CDM according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles in one triangle can join to all three angles in another triangle, then you actually proved that those two triangles are similar to each other according to angle similarity rule. And from the fact that triangle CYE is similar to triangle CDM, we will conclude that the following equality is true. We will conclude that CE over CY in the green triangle CYE equals to CD over CM in triangle CDM. So I will repeat again. We'll conclude that CE over CY in triangle CYE equals to CD over CM in triangle CDM. I'll repeat again. We conclude that CE over CY equals to CD over CM, or CE over CY in triangle CYE equals to CD over CM in triangle CDM. Okay. So CE over CY, what is the value of CY? The value of CY, it is actually, it equals to 2 units. So CY equals to 2 units and all equals to CD. What is the value of CD? The value of CD, it is actually equals to 1 unit over CM. What is the value of CM? CM equals to R plus 2 and R equals to 1. So CM equals to 1 plus 2. That is to say it equals to 3 units. So in total, we found out that CE over 2 equals to 1 over 3. We will multiply equation number 3 by 2 and we will get that CE equals to 2 over 3 units. So we can write here that CE equals to 2 over 3 units. And what is the value of ED? The value of ED, it is actually equals to CD minus CE. So actually ED, you can see from the drawing that ED equals to CD minus CE. I will repeat again. From the drawing you can see that ED equals to CD minus CE. So ED equals to CD, that is 1 unit, minus CE, that equals to 2/3. 1 minus 2 over 3 is third. So we found out that ED equals to 1 over 3 units. ED equals to 1 over 3 units. ED equals to 1 over 3 units. So we can write here that ED equals to 1 over 3 units, and what is the value of OE? You can see from the drawing that OE equals to OD plus DE. So OE equals to OD plus DE. So OE equals to OD equals to 1, and DE equals to third. In total, OE equals to 1 plus third. 1 plus third is 4 third, 4 over 3 units. OE equals to 4 over 3 units. Again, OE equals to 4 over 3 units. So here, in the next step, we will join together points O and B by a straight line. And then we'll calculate the size of angle OEB. We will calculate the size of angle OEB, this angle. So angle OEB is located here. Angle OEB is located here. We will calculate the size of this angle, angle OEB, from this drawing. We have the rule that states that the sum of the angles in one side of a straight line, on one side of a straight line, equals to 180 degrees. So if we focus on this side of the straight line CO, CO is the radius of the middle circle, so it is absolutely a straight line. So if we focus on this side of the straight line CO at point E, this point E, the sum of the angles at this point on this side of equation, or on this side of the straight line CO, the sum of the angles must be equal to 180 degrees. That is to say, this angle that is a right angle, it equals to 90 degrees, plus the size of angle OEB, must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So the sum of the angles on one side of the straight line OC at point E must be equal to 180 degrees. That is to say, 90 degrees plus the size of angle OEB must be equal to 180 degrees. Here we will subtract 90 degrees from this equality, and we will get that the size of angle OEB, it is actually equals to 180 degrees minus 90 degrees, it equals to 90 degrees. So angle OEB is a right angle, it equals to 90 degrees. So this angle is a right angle, it equals to 90 degrees. So we can this angle is a right angle, angle OEB equals to 90 degrees. So if angle OEB equals to 90 degrees, then triangle OEB is a right angle. So I will draw again the right triangle, triangle OEB. So I do again the right triangle OEB. We know that OE, we already found out that OE equals to 4/3 units, and OB is the radius of the semicircle, that is to say it equals to 4 units, and the only thing that is left to find is to find out the length of side EB. And we will do it according to the Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle OEB is OB. Therefore, the square of the hypotenuse is OB squared. Equals to the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, it equals to OE squared plus EB squared. I repeat again. In the right triangle OEB, according to the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. That is to say, OB squared equals to OE squared plus EB squared. OB equals to 4 units. Therefore, OB squared is 4 squared. 4 squared is 16. Equals to OE squared. OE equals to 4/3 units, so OE squared is 4/3 squared plus EB squared. Three over 4 squared is 16/9, so we write it down. 16 equals to 16/9 plus EB squared. We will subtract 16/9 from equation number 4, this equation, and we will get that 16 minus 16/9 equals to EB squared. We will multiply 16 by 9, and then we will divide it by 9 in order to have a common factor with 16/9. So we will get that according to equation number 4, 16 times 9/9 minus 16 equals to EB squared. Here 16 times 9 minus 16 is 16 times 8, so we write it down. 16 times 8/9 equals to EB squared. So we got that 16 times 8/9 equals to EB squared. 16 is 2 times 8, so we will substitute 16 by 2 times 8, and we will get that Here we will take a root out of equation number 4 and we will get that EB equals to the square root of 2 times 8 times 8 over 9. The square root of 8 times 8 is 8 and the square root of 9 is 3, so I write it down. We will get that EB in total will equals to 8 over 3 times square root of 2 units. So we found out the value of EB. It equals to 8 over 3 times square root of 2 units. So in the next step, we will prove that those two right triangles can go into each other. We will actually prove that those two green right triangles can go into each other. So I will draw again those two right triangles and we will prove that they can go into each other. Okay? So we will prove that those two right triangles can go into each other. AO equals to 4 units and OB also equals to 4 units. They are the radiuses of the semicircle. So AO equals to OB equals to 4 units. AO equals to BO equals to 4 units. And OE is a common side. It belongs to both triangles. So OE equals to OE is a common side. OE equals to OE is a common side. By proving that those two sides can go in both triangles, we actually proved that those two triangles can go into each other according to rule number 4. And what is rule number 4? Rule number 4 is actually rule number 5. According to rule number 5, those two right triangles can go into each other. So what is rule number 5? Rule number 5 states that according to rule number 5, if the hypotenuse and a perpendicular in one right triangle congruent to the hypotenuse and a perpendicular in another right triangle, then the right triangles can go into each other. So I will read rule number 5 again. Rule number 5 says that if the hypotenuse and the perpendicular in one right triangle can go into the hypotenuse and the perpendicular in another right triangle, then the right triangles can go into each other. And we actually proved that the hypotenuse OB and the perpendicular OE in the right triangle OEB can go into the hypotenuse OA and the perpendicular OE in the right triangle OEA. Therefore, we actually proved that those two right triangles can go into each other according to rule number 5. So according to rule number 5, the two right triangles can go into each other. That is to say, the right triangle OEB can go into the right triangle OEA according to rule number 5. I will repeat again. Triangle OEB congruent, this is the sign of congruent. Triangle OEB congruent to triangle OEA according to rule number 5. And from the fact that triangle OEB congruent to triangle OEA, we will conclude that AE equals to EB. Side AE equals to side EB. AE equals to EB. According to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides AE and AB will be also equal to each other. And what is the value of AB? From the drawing you can see that AB equals to AE plus EB. Equals to AE plus EB. Again, AB equals to AE plus EB, but we have already found out that AE equals to EB, so we can substitute AE in this equality by EB. Okay, so we'll do it now and we'll get that AB equals to EB plus EB. That is to say, AB equals to 2 times EB, and we have already found out that EB equals to 8 over 3 times square root of 2 units. So in total, AB equals to 2 times 8 is 16 over 3 times square root of 2 units, or in terms of numbers, it equals to 7.54 units. Again, AB equals to either 16 over 3 times square root of 2 units, or in terms of numbers, chord AB equals to 7.54 units. So I will show it also in the drawing, in the original drawing. Chord AB equals to either 16 over 3 times square root of 2 units, or in terms of numbers, chord AB equals to 7.54 units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the size of chord AB, the length of chord AB. We have here a semicircle. Inside this semicircle we have 3 circles. Those 2 small circles are identical, and the middle circle is tangent to the semicircle at point O. Point O is also the center of the semicircle, and point C, this point, is the center of the middle circle, and PQ, that is the diameter of the semicircle, equals to 8 units, and the diameter is always twice as large as the radius. So if the diameter equals to 8 units, then the radius will be equal to 4 units. So the radius PO of the semicircle will be equal to 4 units, and the radius OQ of the semicircle will be equal to 4 units, and the radius OX of this semicircle will be also equal to 4 units. But OX is not only the radius of the semicircle. OX, it is actually also the diameter of the middle circle. So if the diameter of the middle circle equals to 4 units, then the radius of the middle circle will be equal to half of it. That is to say, it will be equal to 2 units. That is to say, the radius CX of the middle circle equals to 2x, and the radius OC of the middle circle also equals to 2x, and CY, that is also the radius of the middle circle, equals to 2 units. We also know that AB is parallel to PQ, and we joined points M and C by a straight line. M and C are the centers of those circles, the small circle and the middle circle. The distance between the centers of 2 circles with an external line between them, like in this drawing, it equals to the sum of the lengths of their radiuses. That is to say, it equals to R plus 2. Then we join points M and N together by a straight line. Mn is the radius of the small circle, and this radius is drawn to the point of tangency, that is to say, to point N. Therefore, the tangent PQ will be perpendicular to this radius, that is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, the radius CO of the middle circle, it is drawn to the point of tangency, that is to say, it is drawn to point O, that is the point of tangency. Therefore, the tangent PQ will be perpendicular to this radius, that is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Then, from point M, we drew perpendicular to CO, so this angle is 90 degrees, and this angle also equals to 90 degrees. Okay? And I drew again the perpendicular MNOD and the triangle, the right triangle MOD, and we have the rule number 1 that states that corresponding angles between parallel lines are equal to each other. Okay, so here, because of the fact that here we have here EY is part of AB, and AB is parallel to PQ, and NO is part of PQ, therefore YE will be parallel to NO. So we know that YE is parallel to NO, and we have rule number 1 that states that corresponding angles between parallel lines are equal to each other. So we know that YE is parallel to NO, therefore those two corresponding angles that are located between the parallel lines YE and O will be equal to each other. And this angle is a right angle, it equals to 90 degrees, therefore it will be equal to this angle, angle CEY. Okay, so actually we will get that angle, I will repeat again, YE is parallel to NO, and according to rule number 1, that those two corresponding angles that are located between the parallel lines CE and NO will be equal to each other. But this angle equals to 90 degrees, so this angle that equals to 90 degrees will be equal to this angle that is actually angle CYE, that is actually angle CEY. So we will get that 90 degrees equals to angle CEY, or angle CEY equals to 90 degrees. According to rule number 1, this angle, it is a right angle. It equals to 90 degrees. Okay? As you can see, quadrilateral MNOD, in quadrilateral MNOD we have 3 right angles. 1, 2, 3. And we have rule number 1, rule number 2 that states that the sum of the angles in any quadrilateral equals to 180 degrees. So in quadrilateral MNOD, the sum of the angles equals to 360 degrees. That is to say, the sum of the 3 right angles is 270 degrees, plus the size of this angle that is defined as angle X must be equal to 180 degrees. 270 degrees plus the size of angle X must be equal to 360 degrees, according to rule number 2. This rule number 2. We subtracted 270 degrees from this equality, and we got that angle X equals to 90 degrees. Angle X equals to 90 degrees. So this angle is a right angle. Therefore, all the angles inside quadrilateral MDON are right angles. They are equal to 90 degrees. And we have rule number 3 that states, according to rule number 3, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So this quadrilateral MNOD that has 4 right angles must be at least a rectangle, if not a square. So we will relate to quadrilateral MNOD as a rectangle. It is actually a rectangle, okay? And we have also rule number 4 that states that the opposite sides of a rectangle are equal to each other. The opposite sides of a rectangle are equal to each other. That is to say, MD equals to NO and MN equals to OD or DO. Okay? As I already said, according to rule number 4, MN equals to the opposite sides NO. According to rule number 4, but we know that MN equals to R, it is the radius of the small circle. From this equality we will conclude that DO also equals to R. DO also equals to R, so we can write here that DO equals to R. Okay, what is the value of CD? You can see from the drawing that CD equals to CO minus DO. CO minus DO equals to CD. CO minus DO equals to CD. But CO equals to 2 units and DO equals to R. So in total we found out that CD equals to 2 minus R. CD equals to 2 minus R. What is the value of CM? CM is the distance between the centers of the small circle and the middle circle. Therefore it equals to R plus 2. So we focused on the right triangle CDM. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is CM and the square of the hypotenuse it is CM squared. CM squared equals to CD squared plus DM squared, according to the Pythagoras theorem. But we know that CM equals to R plus 2, therefore CM squared will be equal to R plus 2 squared. CD equals to 2 minus R, therefore CD squared will be equal to 2 minus R squared plus DM squared. We open the brackets of equation number 1 in both sides of equation number 1, and we found out that R plus 2 squared equals to R squared plus 4R plus 4, and 2 minus R squared equals to 4 minus 4R plus R squared plus dm squared. Here we have R squared on both sides of equation number 1, so R squared will get cancelled, and we have also 4 on both sides of equation number 1. So 4 also will get cancelled, and what is left from equation number 1 after we cancel those two expressions, what is left, it is actually in this side of equation number 1, what is left is 4R, and on the other side of equation number 1, what is left, it is actually minus 4R plus MD squared. Here we added 4R to this equation, equation number 1, and 4R plus 4R is 8R. 4R minus 4R is 0, so we, in total we got that 8R equals to dm squared. We took a root of this equation, equation number 1, and we got that dm equals to the square root of 8r, but 8 is 4 times 2, so we substituted 8 by 4 times 2 here, and we got that dm equals to the square root of 4 times 2 times r. The square root of 4 is 2, so in total we got that dm equals to 2 times square root of 2r. Okay, we found out that dm equals to 2 times square root of 2r, but according to rule number 4, that the opposite sides of a rectangle are equal to each other, we will get that md equals to no. md equals to no. According to rule number 4, md equals to no. But we already found out that md equals to 2 times square root of 2r. From this equality we will conclude, we will derive that NO also equals to 2 times square root of 2r. Okay, NO equals to 2 times square root of 2r. We wrote here that NO equals to 2 times square root of 2r. Then we focus on the green right triangle M and O. We join together points M and O by straight line. And we found out the value of MO. What is the value of MO? First of all, we join together points M and O by a straight line. We join together points M and O by straight line here. Then we join together points A and M by straight line. AM is the radius of the small circle, that is to say it equals to R. And what is the value of MO? MO, you can see from the drawing that MO equals to AO minus AM. AO minus AM equals to MO. AO minus AM equals to MO. But we know that AO is the radius of the semicircle. It equals to 4 units. You can see that AO is the radius of the semicircle. It equals to 4 units. And AM equals to R. It is the radius of the small circle. AO equals to 4 units. AM equals to R. So MO equals to AO, that is 4 units, minus AM, that is R. So in total we found out that OM equals to 4 minus R. OM equals to 4 minus R. So we can write here that OM equals to 4 minus R. OM equals to 4 minus R. And we know that MN equals to R. And NO equals to 2 times square root of 2R. So we implemented the Pythagoras theorem in the green right triangle MNO. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, MO square equals to MN square plus NO square. We already found out that MO equals to 4 minus R. Therefore, MO square will be equal to 4 minus R square. That equals to MN square. MN equals to R, so MN square will be equal to R square plus NO square. NO equals to 2 times square root of 2R. Therefore, NO square will be equal to 2 times square root of 2R square. Here we open the brackets on both sides of equation number 2, and we got that 4 minus R square equals to 16 plus R square minus 8R. And it equals to R square, and the square of 2 times square root 2R is 8R. Here we have R square on both sides of equation number 2, so R square will get cancelled. And we added 8R to this equation, equation number 2, and we got that 16 minus 8R plus 8R equals to 16, and 8R plus 8R equals to 16R. In total we got, according to equation number 2, that 16 equals to 16R. We divided equation number 2 by 16, and we got that R equals to 16 over 16. 16 over 16 is 1, so R equals to 1 unit. We found out that R equals to 1 unit, so here we can write down that R equals to 1 unit, R equals to 1 unit, and CD equals to 2 minus R, and R equals to 1, so CD equals to 2 minus 1, that is 1, so CD also equals to 1 unit. Then what is, then we actually proved that those two right triangles, that the green triangle is similar to the right triangle, triangle CDM. We focused on triangle CY, the green triangle, triangle CY, on the and on the right triangle, triangle CDM. And we proved that those two right triangles are similar to each other. Why they are similar to each other? First of all, we know that those two angles, they are equal to each other, they are both right angles. That is to say, angle CY equals to angle CDM equals to 90 degrees. And we also know that this angle, angle C, is a common angle because it belongs both to the green triangle, and angle C also belongs to triangle CDM. Therefore, we can write down that angle C equals to angle C is a common angle, angle C equals to angle C is a common angle, and those two angles, they are also equal to each other according to third angle theorem. That is to say, angle CY equals to angle CMD according to third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And here we have the first pair of angles that congruent. They are both equals, they are right angles, they are equal to each other, and this angle is a common angle, therefore it equals to itself. This is the second pair of angles that congruent in those two triangles. Therefore, if we have two pairs of angles that congruent in two triangles, then the third pair of angles must also congruent. Therefore, those two angles must be equal to each other according to third angle theorem. So that is the explanation of third angle theorem. And we actually proved that the third angle theorem is true in the previous lecture. So from the fact that those two angles are equal to each other, we actually proved that all three angles of triangle CEY, 1, 2, 3, congruent to all three angles of triangle CDM, 1, 2, 3. Okay, 1, 2, 3. And therefore, we actually proved that triangle CEY is similar to triangle CDM according to angle similarity rule. And what is angle similarity rule? Angle similarity rule is that if you prove that three angles in one triangle congruent to three angles in another triangle, then you actually proved that those two triangles are similar to each other according to angle similarity rule. And from the fact that triangle CY congruent to triangle CDM, we will conclude that CE over CY in triangle CEY is equal to CD over CM in triangle CDM. CE over CY. What is CY? CY equals to 2 units. It is the radius of the middle circle. So CY equals to 2 units. CD, what is CD? We have already found out that CD, here CD equals to 1 unit. CD equals to 1 unit. And CM, the hypotenuse of triangle CY, the hypotenuse of triangle CDM is actually R plus 2, and R equals to 1, so CM equals to 1 plus 2, that is 3 units. So CM equals to 3 units, CD equals to 1 unit, so in total we got that CE over 2 equals to 1 over 3. Here we multiplied the equation number 3 by 2, and we got that CE equals to 2 over 3 units. CE equals to 2 over 3 units, and what is the value of DE or ED? ED equals to CD minus CE. ED equals to CD minus CE, but CD equals to 1 unit and CE equals to 2 over 3 units. So in total, ED equals to 1 minus 2 over 3 units. 1 minus 2 over 3 units is third. So we found out that ED equals to third, CE equals to 2 third, and CD equals to 1 unit, and the radius equals to 1 unit too. Okay, and what is the value of OE? The value of OE, it is actually equals to OD plus DE. Okay, OE equals to OD plus DE, but OD equals to 1, it is the radius of the small circle. OD equals to 1, and we have already found out that OE equals to third. So in total OE equals to 1 plus third. 1 plus third is 4 over 3 units. So we found out that OE equals to 4 over 3 units. OE equals to 4 over 3 units. Then we actually found out the value. Before that, we actually connected together points O and B by a straight line. We connected together points O and B by a straight line, and we found out the size of angle OEB, the size of this angle, and we actually found it in this drawing. We found out the size of this angle, angle OEB. We know that this angle, angle CEB, is a right angle. It equals to 90 degrees. And we have the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So if we focus on this side of the straight line CO at point E, the sum of the angles must be equal to 180 degrees. That is to say 90 degrees plus the size of angle OEB must be equal to 180 degrees. Again, 90 degrees plus the size of angle OEB must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So the sum of the angles on this side of the straight line OC must be equal, at point E, must be equal to 180 degrees. That is to say 90 degrees plus angle OEB must be equal to 180 degrees. 90 degrees plus angle OEB must be equal to 180 degrees. Here we subtracted 90 degrees from this equality and we got that angle OEB equals to 90 degrees. So we found out that this angle is a right angle. So if angle OEB equals to 90 degrees, then triangle OEB is a right angle. So I drew again the right angle OEB. We know that we already found out that OE equals to 4 over 3 units and OB is the radius of the semicircle, therefore it equals to 4 units. And the only thing that is left to find is to find out the length of side EB of the right triangle OEB. And we found out the length of EB according to the Pythagoras theorem that the square of the hypotenuse equals to the sum of the squares of the perpendiculars in the right triangle OEB. That is to say OB squared equals to OE squared plus EB squared. OB equals to 4 units, therefore OB squared is 4 squared. 4 squared is 16. OE equals to 4 over 3 units and OE squared equals to 4 over 3 squared. EB squared is EB squared. So 16 equals to 4 over 3 squared plus EB squared. 4 over 3 squared is 16 over 9. So we found out that 16 equals to 16 over 9 plus EB squared. Here we subtracted from equation number 4 16 over 9 and we got that 16 minus 16 over 9 equals to EB squared. Here we multiplied 16 by 9 and then we divided it by 9 in order to have a common factor with 16 over 9. And in total we found out that 16 times 9 minus 16 over 9 equals to EB squared. But 16 times 9 minus 16 is 16 times 8. Okay, so we got that 16 times 8 over 9 equals to EB squared. But we know that 16 is 2 times 8, so we substituted 16 by 2 times 8, so in total we got that 2 times 8 over 9 equals to EB squared. Here we took a root out of equation number 4 and we found out that EB equals to the square root of 2 times 8 over 9. And the square root of 8 times 8 is 8 and the square root of 9 is 3. So in total we got that EB equals to 8 over 3 times square root of 2 units. Then we actually proved that those two right green triangles can go into each other. I copied those two right triangles and we proved that those two right triangles can go into each other. First of all, we know that OA equals to OB equals to 4 units. They are the radiuses of the semicircle. And OE is a common side that belongs to both triangles. So OE equals to OE is a common side that belongs to both triangles. So in this way, we actually proved that according to rule number 5, that those two right triangles can go into each other. What is rule number 5? Rule number 5 states that if the hypotenuse and a perpendicular in one triangle can go into the hypotenuse and the perpendicular in another right triangle, then the right triangles can go into each other. And we actually proved that the hypotenuse OA in the right and the hypotenuse OA and the perpendicular OE in the right triangle AOE congruent to the hypotenuse OB and the perpendicular OE in the right triangle OEB. Therefore, we proved that those two right triangles congruent to each other according to rule number 5. And from the fact that those two right triangles congruent to each other, we will conclude that triangle OEB is congruent to triangle OAE according to rule number 5, and we will conclude from it that AE equals to EB, AE equals to EB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides AE and EB will be also equal to each other. And what is the value of AB? AB equals to AE plus EB. AB equals to AE plus EB, but we already found out that AE equals to EB, so we can substitute AE by EB. So we substituted AE by EB, and we got that AB equals to EB plus EB. That is to say, AB equals to 2 times EB, and we have already found out that EB equals to 8 over 3 times square root of 2 units. So 2 times 8 over 3 times square root of 2 units, it is actually 16 over 3 times square root of 2 units. So in total we got that AB equals to either 16 over 3 times square root of 2 units, or in terms of numbers, AB equals to 7.54 units. So I'll repeat again. Chord AB, the length of chord AB, it is actually either 16 over 3 times square root of 2 units, or in terms of numbers, chord AB, the length of chord AB, it is actually 7.54 units. Okay, thank you very much.